This is a question on Simpson rules application. It's two application of Simpson rule. One of the questions on the half-yearly exams of the general class, the HSC class. About a few of them were able to do the first step. It's the second part that was a bit difficult. The question says a piece of plaster has a uniform cross-section which has been shaded and has dimensions as shown. Now, the students are familiar with the shaded part, which is, that's what we're indicating to. And it's a cross-section of a plaster. Whether they know or not what a plaster is, it is not really important at the moment. There is a piece of a solid piece in front of them, so they can work it out. Now, it says here use two applications of Simpson rule. The formula is given as well. Now, my main concern was being able to know that the height here is 0, and they already know they're going to divide this question into two parts. So if I put a line there, so the first application will be for area 1, and that would be area 2. Now, it's already been divided, the 14.4 centimeters, into 4 parts, 3.6. So they should know the height, h here, will be 3.6. Okay? Now, let's apply the rule. For area 1, we have 3.6 over 3. It's the height over 3. The first height, for the first part of the area, we start with the 5 plus 4 times the middle distance, which is 4.6, plus the last distance for area 1 is 3.7. For area 2 would be 3.6 over 3. Now our first distance will be 3.7 plus 4 times 2.8 plus 0. So this 0, some students made a mistake with this part. Okay, doing calculation on a calculator for the whole thing and adding them, the two areas, the total would be 32.524 plus 17.88. Adding the two together would be 50.40, or to the nearest square centimeters would be 50 squared centimeters. In the meantime, we leave it as that. So the answer, if you say to the nearest, will be 50 squared centimeters, and that was worth 3 marks. Now, looking at the second part, you're given the total surface area of the piece. That's the total surface area of the piece is 7,480.8 square centimeter. So that's including the whole, every side, the front, the back, and the curved surface, and everything else. Now, the question is asking about the curved surface area, which is that top part. Now, we already found through Simpson rule, this is about 50 square centimeters, and from the other side, of course, there's another 50 square centimeters. Now, some students did not realize this back part here, to find the area of this one and to find the area, so this is the back, and the bottom. Another thing, there's the 2 meters here and everything else in centimeters, so they should change the 2 meters to 200 centimeters. All these little things should have been taken into consideration. So now, if I want to calculate the back part of this solid, will be 200 times 5, which gives me a 1,000 squared centimeters. So this one is the back of this solid piece. Another one that we need to calculate is the bottom part. The area of the bottom part would be 14.4, which is the length from this part to this part. times 200, and that gives us 2,880 squared centimeters. Now we know. Now we add the ones that we just found, the bottom, the back, and the two sides of Simpson rule. So that will give us 2,880 plus 1,000 plus 100, which gives me a total of 3,980 squared centimeter. Now we were given earlier in the question the total surface area of this space is 7,480.8. So to find the curved part, which is the one that's missing, we'll just subtract. So the curved surface area would be 7,480.8, take away 3,980, and that leaves you with 3,500.8 squared centimeters. So just a few little mistakes some students missed. It cost them a couple of marks. This is how you find the surface area of the curved surface area of this shape.